All right, the door's closed. It's almost 2 p.m. Let's get started here. This talk is called Developing Class Consciousness, and my name is Mathias. We're all happy to be back in person at PSConfEU. Like, I'm pretty excited about this. Yeah? Okay. I've basically been waiting 3 years for this, just been sitting at home, writing PowerShell and not having to show it to anyone. It's been terrible. So we're going to make up for that today. I've curated and sort of collated a bunch of examples that show maybe some of the aspects of the PowerShell class feature that not everyone is aware of, or that people maybe don't usually dive into, for good or for bad reason. And so we're going to have a look at that. First of all, thanks to our sponsors, of course, Squared Up, Automator, Patch My PC, Chocolate Cheese System Frontier, and Script Runner. We have a lot to go through here. So, as I said, my name is Mathias. Professionally, I work as a threat detection engineer at a travel tech company called Booking.com that you might have heard of. I consider myself, sort of outside my professional sphere as well, a PowerShell aficionado. And in 2022, I also feel comfortable describing myself as a tired person. I don't know if any of you can relate to that. Why am I here? Why am I talking about this particular subject? And why do I think that I'd be a good person to maybe educate you a little bit on it today? Well, I happen to be the first community member to fix multiple bugs in the PowerShell classes types of system. As many of you know, PowerShell has been open source for 5 years, I think. And so anyone can go in and see, oh, there's an issue in PowerShell here, there's a bug. Maybe I can fix it, maybe I can open a pull request in GitHub, and then you can actually sort of participate in and contribute to the further mission of PowerShell by helping fixing things. And so I sort of jumped into this a couple of years ago and managed to find a couple of bugs in this particular subsystem of PowerShell that I was able to help fix. I also know way too much about .NET's type system. A couple of years ago, I did a series of talks at this very conference called How to Become a Type System Ninja, where I sort of detailed a year and a half's worth of research into how the .NET common type system works, and how I had used that knowledge to sort of create an experimental module for PowerShell that allowed you to define something called interfaces, which is a type contract in .NET, at runtime. A few of you might have played around with Legislator, as it's called, this module that allows you to create interfaces at runtime. It has very limited utility. We might get into why that is, but I found it very interesting, and so if you find type systems and .NET interesting, you might find it interesting as well. Finally, my last bona fide is that as of April 2022, I'm also a community member of the Engine Working Group. So I meet up every 2 weeks with a group of people, both community members and people from the PowerShell product team, and we discuss sort of the issues of the day. There might be bugs or specific behaviors or things we might want to change in the language engine itself, and so that's sort of the forum where we discuss and prioritize those issues. Okay. Well, thank you. I also know that the product team at Microsoft is eager to expand this further, so if any of you are interested, not necessarily in the engine or the language aspect of PowerShell, but I think Rob mentioned in the keynote that there's 5 or 6 different working groups focusing on things like developer experience, commandlets and modules, so on and so on. So if you feel you have something to contribute with, or if you think what's coming out of the working groups is not working for you, then you should definitely go to the discussions page on the PowerShell GitHub and register your interest in joining the working group. First of all, I need to clear up sort of when the schedule for PSConfEU first came out, I made sort of a joke alluring to the fact that this was a Marxist talk about freeing the proletariat because of the ambiguity of the sentence class consciousness. I just want to make absolutely sure that this talk is about classes, the object-oriented programming concept, not the socio-economic concept posited by Karl Marx. Just, we're all on the same page, right? Okay, good. Okay. With that out of the way, let's have a look at what we are going to have a look at today. When I first started putting together the agenda for this talk a couple of months ago, I started with this question, what are PowerShell classes, right? And I was sort of having an emotionally weak moment, and it quickly devolved into like an existential crisis almost, right? What is PowerShell? What? And in the interest of not sort of taking you with me on like a downward spiral into figuring out what the purpose of life is, I'm going to, yeah, 42, right? Okay, so we can skip that part then. Okay, excellent. I am going to posit one of these questions, but I'm going to try to keep it as short as possible. So the agenda ends up looking like this. For the first 10 minutes, I'm going to talk and go through some slides about what are classes. Conceptually, what is a class in the context of .NET. And then finally, how we can sort of view PowerShell classes as a subset of the similarly named feature in C#, the programming language that PowerShell is primarily implemented in. Then we're going to have a super quick sort of PowerShell classes 101. I'm just going to write up a couple of like example class definitions in my editor, and we're going to see how they behave and what you can use them for and what the syntax looks like. And then finally, we sort of get to the meat of the talk. The last half is just going to be what I call advanced examples. I find it really hard to gauge how familiar and how sort of comfortable people are with this particular sort of late feature entry into the language. I know some people have dug into it deep and have found all sorts of things you can do with classes and have found many of the limitations. I also know a lot of people have sort of tried to make it a better developer experience and not always been successful. I'm going to present a couple of examples that touch on how we can sort of hook into or integrate into existing facilities in PowerShell and .NET. We're going to have a little bit of a look at thread safety and concurrency or concurrencyfication. I don't think that's a word, but I put it in there. We're going to have a look at thread safety, right? 5 years ago, I'm not sure I would have included this in a talk about PowerShell classes, but with the advent of PowerShell 7 and all the parallelization options we have, right? We have built-in thread jobs that you can parallelize. You have for each object parallel and so on and so on. I think it might be worth sort of just surface area, have a look at how we can ensure and implement thread safety for when we sort of access from multiple run spaces or threads the same data store, basically. Finally, if we have the time, we're going to sort of dig a little bit into sort of using classes for boilerplating. That is, you write some code and then you get some repetitive behavior in further class definitions or the objects that you create for them. And I think that's it. Disclaimer, before we sort of dig into this, the developer experience sucks. I know, it just does, right? Like, PowerShell classes are sort of an afterthought feature, right? When PowerShell 5 was released, the big thing of the day, the big theme was DSC, right? The PowerShell team at Microsoft needed to enable developers, admins, me, you, all of us in here, right? To write sort of sensible DSC components using the PowerShell syntax, and there were some things missing that didn't really sort of mesh well with, you know, transpiling your PowerShell configurations into MOF files and so on and so on. And so one of the abstraction layers that they decided to introduce was enums and classes, right? So again, this ability to sort of define types at runtime. That was sort of the primary point, right? Incidentally, it enabled a bunch of other use cases way outside the scope of DSC, right? And some people started using it, myself included, right? Started using it for some use cases that it certainly wasn't intended for in the first place. And so again, some of these sort of accidentally work because of the way this was implemented for DSC, but we won't spend too much time on all the things that you can't do with PowerShell classes because they are a little bit rocky, right? They are a little bit of an afterthought just by design. Again, yeah, it's definitely the roughest feature set in the language, right? We could probably do a 5-day workshop on these two topics alone, and you'd all go home and say, I never want to touch PowerShell again. So we're not going to do that. We're not going to dig too deep into it. Today is about planting seeds, right? This was what Rob was talking about in his keynote just now. We want to give you some ideas that you can go home with and say, like, oh, I can do this with this thing. I didn't know that, right? And then you can sort of figure out how you can implement that in your own local context. So, I told you I was going to posit this question anyways. What is PowerShell? Any ideas? Any labels you want to stick on PowerShell? What is PowerShell?
An administrative and scripting language.
An administrative and scripting. That's a pretty good answer. Yeah.
Command line processor.
A command line processor. Yeah, for sure. Yeah. Any other ideas, labels, names we can apply to PowerShell? Yeah, Jakob.
Integrated C#.
What? Integrated C#, yeah, sort of. Integrated and opinionated C#, I would say. There are some limitations and some stuff on top, but yeah, close enough. An interface to the common language runtime, yeah, also a good example of what PowerShell is. The aspect of PowerShell I want to talk to about today is the scripting language itself, the language. So I think we can call PowerShell a programming language, right? Nobody's going to take offense if I call PowerShell a programming language, right? Okay, otherwise leave, please. Okay, so the question becomes, what is a programming language? Any guess? It could be, yeah. It's a feature of many programming languages. I don't think it's a prerequisite, though.
The language which you talk to the computer.
Aha, okay, so now we're getting somewhere, right? So a programming language is sort of roughly a set of rules and some tools that sort of follow and enforce those rules that turn human-readable code into CPU instructions, right? That's the entire purpose of programming languages. We write something that we can sort of reason about with our language, with our human language, and then we have a program, we have a set of tools, right? We have a compiler, something like that, that turns it into something that the CPU can then interpret and execute. And this programming languages typically include lots of templating features, right? So we can write something and then parameterize it, and we can sort of reuse it many times, so we don't sort of need to write all the CPU instructions, right? That's sort of the whole point. The problem is that CPU instructions operate on this, right? Strings of bits, zeros and ones, right? Like we've all heard this. So the CPU is optimized to operate on this, and we humans trying to reason about these CPUs that we've built and that we're trying to use, we start sort of applying abstractions to bigger and bigger chunks of these strings of zeros and ones, right? So we say that a sequence of 8 bits is a byte. Then at some point it turns out that there are only 256 states, 256 values that you can express with only 8 bits, right? 2 to the power of 8. That's limiting, of course, so in the 80s and the 90s, we start getting 16-bit computers, right? So we're just gonna squash 2 of these together. We're gonna call it a word, right? This is the memory model in the earliest versions of Windows, for example, 16-bit operating systems, right? And then over time, we've sort of added more and more abstractions on top of these existing abstractions that we sort of map onto the CPUs, right? And so the CPU knows what a 64-bit integer is, for example, or a quad word, if we're sort of sticking with the 16-bit terminology. The CPU knows what that is, but the CPU does not know what a string is. It does not know what a web proxy object is, right? It does not know what an HTTP request is. It just knows ones and zeros in these sort of slices, right? So the whole purpose of a programming language is to take our cognitive load off of having to think of these strings of zeros and ones and all the operations we have to apply to them by applying sort of human language like templating engines, basically. And so that's what a class is. A class is an object templating feature in many OOP languages. So in a language like C#, Java, C++, these languages that are known as sort of class-based, object-oriented languages, it is sort of the core unit of work, right? Like everything is a class. Obviously, there are some other data types in both C#, Java, C++. We have primitive data types, so numbers, the integers that the CPUs can understand. We might have a string type in Java and C#, right? But other than that, most of sort of the complicated data that we express in these languages, we use something called a class as a templating feature. .NET is entirely self-tuned around this idea of portable classes, right? You sit down, you write some code. The code you write is organized into classes. You push that through your compiler, and the compiler gives you something called an assembly file, a DLL, right? A dynamic link library on Windows, for example. And that's then going to contain all the metadata from the program along with not the CPU instructions, but the virtual machine instructions for the common language runtime. And the idea is that the classes themselves, after you've compiled them, are still portable, right? So Irvin down here can write a piece of C#, he can compile that, he gets a DLL out, and then he can send that to me, and the DLL file has both the code and enough metadata for me to be able to reuse it without having direct access to his source code, right? This is pretty smart. That means that we don't need to copy-paste source code all over the place. We rely heavily on these in PowerShell, right? Every single object that you touch in PowerShell, whether interactively or in a script or in a pipeline or wherever it is, everything you interact with is an object in PowerShell, and all of these objects are bound to a class definition, typically written in C#. So what is an object? Well, an object is a thing in our runtime environment. It's a thing that has both data and code attached, right? And so the term data here is very broad and self-referential in nature, right? The data contained in a class can also be data that's defined by another class or the same class, right? So we can make recursive data structures, for example. Again, in the context of .NET, objects are certain types, right? And they have identity. That means that if we have two similar objects, we can distinguish that this is not the same object as the one over here, even though they sort of look the same or maybe contain some of the same values, right? So this is a very important concept, especially in PowerShell. All objects have identity. Okay, so why is it so important for me to talk about .NET specifically? Well, as I mentioned before, and as most of you know, PowerShell is implemented in .NET, right? All the APIs are written in C#, mostly. And PowerShell's own runtime and type system is not bootstrapped sort of from scratch, right? It's sort of piggybacking onto the existing runtime that's provided by .NET. So we get sort of all the behaviors of the type system in .NET. We get sort of all the runtime behaviors for free. And then we add a bunch of stuff on top of it to make PowerShell sort of a more flexible language, right? PowerShell classes, as introduced in PowerShell 5, facilitates real .NET types. What do I mean by this? I mean that it facilitates creating the same types of types or that you would be able to define in a language like C# or Visual Basic, for example. So we haven't had that ability without calling out to an external compiler previously in PowerShell, right? So prior to PowerShell 5.0, if you want to actually write some .NET code, you need to invoke something like add_type, for example. Add_type is then going to take your raw source code, C# or VB or whatever it is, and then it's going to write it to disk, invoke a C# compiler, and then it's going to re-import the module it just, or the DLL that comes out of that process, right? With PowerShell classes, for certain use cases, we no longer need add_type, right? We no longer need to call out to an external compiler. Okay, so back to classes in .NET. What are classes in .NET? And again, when I say in .NET, I'm primarily talking about like C#, F#, Visual Basic, these sort of fully fledged .NET languages. So the class is what we might call a compilation unit, right? It's a self-contained sort of set of source code that has multiple things, multiple features that we can add to them as members. That would be fields, which stores data, right? So you can have a type of object. Let's say we create a type of object for a contact card for someone, right? It would have it would probably have an address attached to it that might be a string, right? It might have a postal code, which might also be a string or a number, depending on where you are. And so all of this in .NET, for example, we would store this in fields. So this is just sort of static, or this is just data storage. Then we have methods. A little bit cognitive functions in PowerShell, right? This is behavior, right? It's a set of statements, code that needs to run at a certain time on given input, right? So again, templating features, right? We're telling the computer what we want to execute at a later time. We have constructors, which is initializer behavior. These are special methods that are always called when you create an object using a class as sort of the blueprint, right? They have properties. I don't know how many people know this here, but properties do not actually store data in .NET. Properties are like a special interface for accessing data through a filter, basically. So when you access a property, PowerShell internally calls a method somewhere that then returns the data that you actually want. Properties are not actually storing the data themselves. Finally, again, in these compiled languages, we have some constructs like events and delegates, special future behavior registration, you could call that. And then sort of very common for most, or for all languages in .NET, is that they have single hierarchical inheritance. That means that we can organize our classes or types into a hierarchy, and they will then inherit the behavior that's already defined in the parent entity that they're sort of deriving or extending, right? In .NET, there's a limitation that we can only do single parental inheritance. That means a type cannot inherit from multiple objects, or from multiple other types or multiple other classes. So, as I said, PowerShell classes are sort of a strict subset of this functionality that we find in .NET or in C#, right? And so if we sort of look at it comparatively, PowerShell classes do not have fields. And so you might be asking ourselves, how can we store data in objects based on PowerShell classes? But we'll get back to why that is. But fields cannot be directly declared in PowerShell classes. We have methods, just the same as we know them from C#, VB, whatever. We have constructors that we can implement as well, just like in those languages. Because of sort of the prototype-based object model in previous versions of PowerShell, and that's also sort of the default paradigm in later versions, there's no support for declaring what's known as events or delegates in PowerShell classes. We have little use for them. Event-driven programming is all about, register object event and these sort of awkward registration facilities, right? So we don't care about those. And then finally, we have limited control over inheritance behavior, meaning that there are some design patterns, as they're sometimes called, that you might find in another language like C# or Java that it's just not possible to implement in PowerShell because you don't have the level of control over the inheritance behavior that you would want. So, with this said, I am going to say something extremely controversial now. PowerShell is not a real .NET language. PowerShell is a real programming language that runs on .NET, but PowerShell is not a real .NET language because the hallmark of a .NET language is that it complies with something called the Common Language Specification. And the idea is that there's always a separate compile time step where, as I said before, you take the source code, you feed it to the compiler, and the output is some file format that you can then re-import for further development elsewhere, right? So this aspect PowerShell does not support because the lifecycle model in PowerShell is very different than in these other languages that we're talking about, right? In PowerShell, we basically only have two steps, right? You as a developer sit down, you write your script, encoded as normal text in Notepad, ESE, VS Code, whatever. This is the starting point. You feed that to a PowerShell language engine, usually PowerShell.exe to invoke a script, right? Or maybe you paste it into your command line. And then step number 2 is PowerShell is going to parse it, it's going to compile it, and it's going to run it, and it's going to give you all the output immediately, right? So the lifecycle is way simpler, and sort of the last steps in what we might call the program or the software lifecycle here are all sort of meshed together at the end. And this gives some limitations in terms of portability, right? Because we can't really sort of hook in between the compile and the run step and then export it to a file format that I can then give to someone else, right? So I can't sit down and write a class in PowerShell and then run some command or execute it in PowerShell exe and then get a DLL that I can then hand off to someone. So PowerShell types created with the class feature are not portable. Of course, your source code is still portable, right? You can write a class definition and you can send that script or that module or whatever it is to a colleague, and they can then recreate the same sort of compilation pipeline. But the compiled classes themselves are not portable. Okay. And then finally, PowerShell is largely a prototype-based language. Does anyone here have any familiarity with languages like JavaScript, Lua? Few? Okay. I thought JavaScript would be more popular these days. But so the idea is that we're not really beholden to sort of a very rigid blueprint for how objects should behave in PowerShell, right? They're sort of they're very dynamic, they're expandable. We can use commands like add member to just like keep ad nauseum adding members or data to existing objects, regardless of the underlying type in the .NET type system, right? And so these things sort of make me conclude that, yeah, no, PowerShell is definitely not a real .NET language, even though it is a real programming language on .NET. Okay, now with all of this nonsense out of the way, we're going to get to the actual interesting stuff here, right? So PowerShell classes 101. I have been like curating and collecting examples for this for half a year, like for this specific talk. And my workflow is usually I see something interesting, I sort of flesh it out either in my terminal or in VS Code, and then I paste it into a private gist on GitHub. Because I'm doing 6,000 things at once, so just being able to sort of just shove it in somewhere and then I can forget about it and access it anywhere later. This works really well for me up until I locked myself out of my GitHub account this very week. So half of the examples that I was hoping to show you are inaccessible to me at the moment. So what I'm going to do instead is I'm going to live code a bunch of these basic examples, and then we're going to see if we can sort of, and then I have a few examples locally that we can go through too, but let's see how this goes. Okay, basic syntax in use. Let's jump over into Visual Studio Code. Is this big, small enough? Can you read this throughout the room? If I do something like, hello all, you can all read this? Yeah. Bigger, small, that's all good? Okay, so in order to define a class in PowerShell, in order to use this class feature to define runtime types, right, it's pretty simple. We just need the class keyword. And Tobias sort of stole my thunder because it was a very similar example I was going to use that he used in his keynote. But the example he used was basically an attendee, right? So the first thing that's worth noting here is that .NET is not nearly as forgiving when it comes to naming things as PowerShell is, right? So in PowerShell we can name most things, almost anything, right? So if you want a function with weird emojis or that's all underscores or whatever, you can do completely what you want, right? The example Tobias gave with like the weird passing error where like 1, 2, 3, 4 becomes null for some reason, right? He also showed that, well, you could basically just do a function called 1, 2, 3, 4, right? This is not going to fly in .NET, right? You can't just use anything in the name of a class. Class names cannot start with numbers, so they have to start with either either a letter or an underscore. I think, yeah, PowerShell doesn't recognize this. So an underscore or an alphabetical character, the name needs to start with that. So, okay, attendee is a perfectly good name then. And then the syntax for classes in PowerShell is very much inspired by the one in .NET. So in order to create a property, we need a type and we need a name. Where it gets a little bit weird is that PowerShell requires us to prefix it with the $ sigil, just like a variable, right? So it sort of looks like a variable. So we can say attendee, okay, they all have a name, right? Okay. So now we have a type definition with the name of attendee that has a single member name, which is a string because we've told PowerShell to type it as such. We can also omit the type constraint on any property completely, and it'll default to system.object, right? The sort of the class that everything else inherits from in .NET. So if we say string, and then let's get someone's age too. So I am going to run the selection. As soon as I execute a document or a snippet in which this class keyword occurs, PowerShell is going to do something that's a little bit unusual. It's going to do a pre-pass round before it does anything. So usually when you execute a script, you're used to it sort of being just step-by-step interpreted, right? So if you write a script that has no syntactical errors, but there's something really weird and wrong sort of further down, it's just going to execute until the error occurs at runtime, and then it's going to error out, right? As soon as PowerShell sees a type definition, either because the class or the enum keyword is present in a script or a script block that you're trying to execute, it's going to attempt to resolve all of the type references inside this type definition. So if I do something like class organizer, so this class down here could be used to represent the organizers of the event, right? So Gail, for example, who's running around trying to make sure that all of this works, he would be an organizer, right? And then we could sort of attach and we could say, okay, so attendees might have a contact person. And then we can assign instances of this organizer class to the attendee class. So if we, again, sort of run the selection of both of these, what we're going to find is that, yes, okay, PowerShell can now resolve this attendee type. We can also have a look at the properties. So you can see here the name, age, and contact person properties that I sort of defined up in the source code here. They're reflected by this real .NET type that now exists and is accessible to me in this scope, right? The same thing with the organizer, right? So this works perfectly fine. I mean, we can try and create an instance of one of these. So we say attendee. Worth noting here is that in order to create instances of PowerShell classes, you need to use this construct right here. There's a new static method that's basically attached to all types of public constructors in PowerShell since version 5. And this is how we invoke the constructor, right? This is how we create a new object. A number of people have been a little confused. I think this has been fixed in PowerShell 7, but in PowerShell 5.0, you can't do new objects and then the name of the custom type you just did, regardless of whether it was already accessible in the scope or whether you just defined it like in the same script. So again, important to, we need to use the new keyword. Okay, so I'm going to create an attendee. So I have this attendee object. Okay, the value of the age default to 0 because that's the default value of an uninitialized integer, right? Name is an empty string and contact person is nothing apparently, or nothing that can be rendered at least. This makes sense. I didn't tell it to fill in any of these values. I just told PowerShell, take this class template, right? Take this blueprint and then create me an object that looks just like this, that has this type, right? And so what I can do is, of course, just like with any other object, right? The object you get back from get process or get service or get content or whatever, you can also interact with this object. Again, this is a real .NET type. So we could do something like, okay, attendee name. Okay. Just like any other object we would expect in PowerShell, it's now reflected, right? And then let's say we want to assign a contact person. So what? Oh, organizer, of course. Thank you very much. And again, I have the ability to invoke the constructor by calling this new method, right? If I call this new method again, then I'm going to have a contact person object attached that doesn't actually have any information, right? Because I haven't provided the name of the organizer, and I haven't really sort of given myself any facility to specify that during initialization, right? During creation of the object. So if I do this now, it's going to sort of receive an empty contact person. So what we can do instead, and I'm just going to scroll up so it's a little more clear here. What we can do instead is we can use, PowerShell has something called new object initializer syntax, which is the exact same facility we use when we do PS custom objects. So probably most of you are familiar with sort of this construct right here, you know, PS custom object. Then we have a dictionary literal or a hashtag literal here, right? And then this will create a PS custom object with those properties attached, right? Everyone familiar with this syntax, right? Okay, so all the same sort of bits and pieces in the parsing engine and the language infrastructure that enables us to sort of do this, like take any dictionary literal and then sort of turn it into an actual object. This is the exact same sort of functionality that allows us to do the exact same thing when casting custom types. So here, I can just put in a hash table literal with the keys corresponding to the properties I want to fill in on that object that we're creating. And then I simply just use a cast operation to make sure that that turns into the object of the type that I just defined here. So I'll say something like Miguel here. And then, okay, so the default string representation just defaults to the type name. You've probably seen this with other types of objects in PowerShell, right? But if we have a look at the sort of the attached associated object, we see here that indeed it created and initialized this object based on my class template and with the property assigned that I actually specified in the hash table literal. I've seen multiple examples online of people sort of going out of their way to write 20 lines of code to sort of go in and then sort of manually fill in all the properties after creating an object, or perhaps creating very complicated constructors. Most of the time, this is going to save you, right? Like if you need to sort of compose very complex object hierarchies, keep in mind that you can actually just cast a dictionary to the type you want, and like PowerShell will take care of everything else. PowerShell is very forgiving when it comes to type conversions, right? And so this is sort of what we're getting here. So the next thing we need to look at is, I said before that classes sort of, or objects join data with behavior, right? Or data with code, right? And so how do we introduce behavior or code to this? Well, we do that by defining something called methods, right? So in the attendee class here, we could do something like, do like a greet method. It's going to return a string with a greeting of some sort, right? And then here, Visual Studio Code is going to tell me that not all code paths returns value within method. This is probably the most confusing error message if you're used to doing PowerShell, the sort of imperative scripting language, and are not used to this sort of class-based programming, because PowerShell would never tell you that, right? If you do function f, and then we can do something like, we can specify the output type, right? The output attribute, right? So this function right here, declares that it's going to return one or more strings, but it's not, because there's no code in there to actually return any strings, right? As soon as someone executes this, nothing is going to be returned, right? But PowerShell is not going to yell at us. PowerShell doesn't care, right? All of this is going to be handled at runtime when it actually fails, and when we're not like seeing the string come back from this. But PowerShell doesn't care, right? It's not gonna yell at us. It's very forgiving again. When it comes to classes, again, because we sort of need to comply with the requirements of the underlying runtime, the .NET runtime, it needs to be a little more strict here. So in this case, I've sort of promised that it's going to get a string back. And in class methods, there's only one way to return anything, at least in PowerShell, and that is by using the return keyword. PowerShell is not going to do sort of a lot of complicated stuff to figure out whether the expression after the return statement is actually a string or not. It's going to defer that until the moment you actually invoke the method, and then it's just going to try its usual conversion magic, right? So I can do something like this, return 1, 2, 3. This literal is invariably interpreted as an integer by the PowerShell parser, right? So this expression is going to return an integer. But so I'm going to create a new attendee. If I use the old one, it's tied to the old definition of our class, right? So I'm not going to get this functionality. So we say greet, and it printed 1, 2, 3. So I guess it returned 1, 2, 3, but I wonder what it actually is, right? So we do something like get member. That should show us the type of the object that it returns. And sure enough, PowerShell has converted it into a string, right? So again, PowerShell being very sort of forgiving with its type conversion magic and all of these things. And so here, the one thing I want to show is that in a method like this, you have access to all the data that's stored in that instance's properties, right? So if I want to reference some state that's stored, right, some data that's actually stored in this object, I use the syntax. So I say this name. This is sort of the second confusing artifact of PowerShell methods, because people usually just do this, right? Like, oh, return name, right? And then PowerShell is going to scream at you again and say variable is not assigned in the method. And it's like, well, it's attached to the object, right? Like I have like the name thing. That's not how that works. This is a local variable. In order to access like the instance variable or the instance property here, we need to use the this qualifier. And so in this case, the resulting class is going to greet us with its own name, which is an empty string right now, so I'm going to create a new object that actually has a name. and it thus returns the data stored in that object itself, right? So this can be pretty useful, and it's mostly useful for persisting data across the lifetime of function calls, right? So in PowerShell, we have this concept of scope, right? Variable scope, type scope, and so on and so on. And this all has to do with the lifetime of the context in which something gets created, right? So if we write a function in PowerShell, for example, again, function f, blah, 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 I'm going to assign a local variable, again, the value 1, 2, 3 here. When we invoke f, PowerShell is going to evaluate this literal value. It's going to store it in a variable called a that's tied to this scope. But as soon as the f function is done executing, poof, it disappears, right? So in many cases, it might be useful to sort of persist data or persist state across this sort of short lifetime of a function call. And classes are really great for that, again, because we sort of have the data and the behavior intertwined. And so I am going terribly over time here if I'm going to go through all these examples. So I am going to ask you to choose some of these. Anyone here using sort of concurrency, thread-safe stuff for each object parallel, trying to optimize their code using that? No, nobody cares, nobody's interested. One guy? Yeah, maybe, okay, so let me show you the problem, right? So I came across this problem about a year ago, and I hadn't really considered this, but someone asked at Stack Overflow, so I'm using these new parallel features, right? For each object parallel, the entire idea is that we can sort of spin up multiple threads and they can work concurrently, and then we can get a lot more done without sort of having to wait for maybe a single slow operation that we can then sort of dispatch to a separate thread. This is great. Like, a lot of people have gotten some mileage out of this feature. The problem is that people start running into some really weird issues that they can't really explain, right? And so someone asked here, I read online, right? I read on docs.microsoft.com that these built-in types, the concurrent dictionary, these concurrent data types, they should make me safe from these thread safety issues, right? And so the question is, if I just create like an outer concurrent data type, one that's thread safe, and then I fill it up with non-thread safe collection types, like a hash table, for example, do they inherit the thread safety of the outer collection? And the answer to that is absolutely not, and I'm going to show you right here. So I'm going to use the PowerShell 7 feature for each object parallel here. I've already created a dictionary object out here, sort of in the calling scope, right? So I'm going to just run these two. Okay, so now I have this dictionary that maps strings to hash tables. Then I'm going to run like 100 iterations for each object parallel. I'm going to obtain a reference using this using directive to this dictionary that I created in the calling scope. Then I'm going to calculate a key. I'm going to sort of fill this dictionary with odd and even values. So I'm going to calculate a key. I'm going to use the facility that this concurrent dictionary provides for sort of thread-safe access to either get a value that's already in the dictionary or update it with a new one. So at this point, this is all thread-safe. Like, you can safely do this with for each object parallel, and everything should be fine, right? So in a thread-safe manner, I obtain the hash table that's mapped to the specific key I want to fill in, and then I'm going to increment a counter that's stored in that hash table, right? And we're going to give it throttle limit 10, so at most 10 concurrent threads are going to be running this piece of code, right? And then finally, we're going to have a look at, like, okay, what values do we actually have? We should expect to have a count of 50 even numbers and 50 odd numbers, right, if we are iterating over 1 to 100, right? So I'm going to execute all of this, and then we see something sort of odd, right? Like, we counted 100 times, but the total comes out to 99, right? Like, there's one of the counters is like missing a value. So what's going on here? Okay, we can make it worse. Like, before I solve it, I'm going to make it worse, right? So I'm going to add a bit of jitter, because that's what happens out in the real world, right? When you have parallel scenarios, you're calling out to a web server, you're calling a database, whatever, and you cannot predict exactly how long or how short that's going to take, right? So we're going to add a little bit of sort of random jitter and see if that has any effect. Now it's way worse, right? We've lost a lot of values here. And so the problem is that at this sort of high abstraction layer, right, the PowerShell is sitting on top of .NET, sitting on top of the CLR, sitting on top of Windows, sitting on top of a hardware abstraction layer, sitting on top of the CPU. If we can't guarantee that the updates or the operations we do are atomic, that is, that the CPU can sort of take them and complete them in one go, then we risk having multiple threads asking the CPU for the same thing at the same time, right? So we end up with a race condition where 3 different threads say, increment this by 1, but internally in .NET, this is split into 2 operations, right? Get the current value out of the hash table and then update that and then push it back in. And so if this happens overlappingly, which it would in a concurrent scenario like this, they're going to sort of overwrite the unupdated values that we just had. So the problem, the way to fix this is to, again, use concurrent data types sort of where you're actually doing the updates, right? Where you're actually doing the concurrent updates. So the only change I've made here is in this storage design, right? Instead of using a hash table, which again is not a thread-safe data type, I'm going to use another concurrent dictionary inside the concurrent dictionary. And so you can see the rest of the code is the exact same, right? So I'm going to run this. And all of a sudden, we don't have any concurrency issues anymore, right? Like, there are no race conditions because some magic code in the concurrent dictionary implementation has taken care of that for us, right? By using a thread-safe collection type, we've now sort of solved the problem. And I only have 10 seconds left. I'm terrible with time. I'm very sorry about that. Any questions that can be answered in 5 seconds? Huh? 42. 42. Okay. I'm afraid this is all. I'm going to include all the code, all the examples that I didn't get to give in the upload to GitHub. I'm going to include lots of examples or lots of inline comments, so you can maybe sort of follow along at home. So again, if this was interesting, look for the upload in the next week, and hopefully you'll get a little more out of it than we did today. Sorry about the time.